You said it works, right? What does it do? This next project has to do with the accelerometer device. So before we get started, we're going to want to go to the library manager, and we're searching for this library so we can install it. Now this is really cool. There's actually, if we go to file here, there's some built-in examples. So we go over to the library we just downloaded and open up the demo. So we're just gonna try to verify and upload this code. Let's twist it this way. We're getting different values here. Twist it down back. Okay, portrait down back. Let's move this around. Portrait down front. Portrait left front. So now as we change this, you can see how this continuously gives us different readings. Now I just added a small little bit of code here that we borrowed from ChatGPT, and it added a timestamp in milliseconds to our output. So this is pretty cool. Yes, now we have finally formatted this in our proper thing, where we get the time on the left over here, and then X, Y, and Z, and those are all just meters per second squared. Right now I'm only getting 0.2s and 0.6s. Now we're gonna run the vibrator. And as you can see, the numbers start changing. So this is the impact that the small vibration had. Notice how it comes in pulses. It goes, no. There's the stop there, yep. And then it's done. Oh, there we go. It's been days, but we finally managed to achieve the log file. Couple of key components. Number one, we needed to get this software serial.h included. We also needed to define the RX and TX ports because apparently they didn't work on 0 and 1 like they did in the diagrams. And now we're able to write data. This is a command that we just created here, but we're just able to write data RX, TX. So next time we come to that command, we're able to print whatever the hell we want. Now another key component is that notice that the RX from the logger here connects to the TX in the Arduino, and the TX from the logger connects to the RX in the Arduino. So we're actually supposed to switch those when we plug them in. Notice the blue light blinking on the open logger. When that happens, that means that the open logger is definitely reading data and storing it to the system. So now that we've got some data being read, we're going to use 3 different experiments to see what we could do. One, we're going to test different vibrations, either really strong vibrations or slow vibrations. We're going to try to smack the Arduino around. We're going to try to walk in the walls. And then we're going to try to just move at different speeds and see what kind of graphs we can come out with our data logger. The first experiment we're going to do is vibrations. So we're sending some vibrations to this phone. We're going to see what it does on the data logger. Ready? 3, 2. Officially beginning experiment number 1. And then we're going to shake it like this.
And at the time we were doing this robotic sand shifter to explain.
On this left side, we can see where we were just doing the phone vibrations, where there wasn't really very much happening in any of the 3 directions. Very small accelerations. In the middle section around here, I started to shake the phone with my hand. And as you can see, the vibrations got a little bit stronger, so you got higher accelerations in all 3 directions. Now on this side, notice there's a huge spike at the very end. That's when I was moving the phone up and down. So that was going with the Z acceleration, which is already really, really high. The reason that the acceleration in the Z is so high already is because of gravity. So when I was going with gravity or against gravity, we got a very change. So that was probably going with the gravity, so you wouldn't get any acceleration because I was going at the same speed as gravity there, right? One of our experiments was dropping things. Hell yeah. And we dropped it from different heights. Beautiful. And as you can see, if it was thrown up or down or hit in the up or down direction, we got major spikes in the Z. But if it was thrown sideways, we would get major spikes or in the X and Y direction. And we could see that the same type of thing would happen in both examples. We're also testing it from just moving around at different speeds. So, as you can see, we're just kind of seeing what happens as we walk around.
Now,
And as you can see, the acceleration lines are much more curved. We kind of did the same thing both times. When it's really, really flat, there's no movement at all. It's completely still. And, well, basically the bigger the lines, the faster it's moving in that direction, because that's just acceleration, not really velocity. But that'd be an interesting graph to plot as well.